Welcome back friends. Welcome back to another video session from this channel. So in this video session we will be studying regarding the termination phase of the transcription mechanism in case of prokaryotes. Is it clear? So what exactly happens during the termination phase of the transcription mechanism in case of prokaryotes? So as I have already mentioned you earlier, synthesis of the mRNA it takes place so accurately during the elongation phase. So once when the specific mechanism or the specific process when it successfully proceeds from the elongation phase into the termination phase, under such condition synthesis of the mRNA which has took place so accurately during the elongation phase, it successfully inhibits during the termination phase. Is it clear? So now here my question is, why the synthesis of the mRNA which has took place so accurately during the elongation phase, it successfully inhibits during the termination phase? So the answer to this question it relies in case of the termination site of the double-stranded genomic sequence. So if we consider the termination site of the double-stranded genomic sequence, the termination site of the double-stranded genomic sequence, it possesses or it consists of high GC inverted repeats followed by high AT rich sequence. Is it clear? So for your better understanding, let me present it on the board. So let me arrange the things here. So let us assume it has the 5' end. And here there is an availability of G, G, C, T, C, C. And here there is an availability of G, G, A, G, C, C followed by multiple thymine nucleotides T, 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 and it is nothing but the 3' end. Is it okay? And here the complementarity of this particular strand it relates in case of the other strand. Is it okay? So let us assume it has the 3' end. So here the complementarity of G is C, again it is C, again it is G, A, G, G, and again the complementarity of G is C, C, T, C, G, G, and here there is an availability of multiple adenosine nucleotides A, and here it is nothing but the 5' end. So here it is nothing but the termination site of the double-stranded genomic sequence. Is it okay? So here once when the specific termination site of the double-stranded genomic sequence when it participates in the transcription mechanism or in the transcription process, it synthesizes the nucleotide sequence of the mRNA. So here I need to mention you one thing. The termination phase of the transcription mechanism in case of prokaryotes, it is successfully organized by the means of two different strategies. So what are the two different strategies here? The very first strategy it is nothing but row independent termination and the other one is row dependent termination. Is it okay? So let me write it on the board. So what it is? Row independent termination and the other one is row dependent termination. Row dependent termination. Is it okay? So here prior to the explanation of row independent termination and row dependent termination, at first let us have a look on the specific factor termed as row. So what is row here? Row is an ATP dependent helicase. It is an hexamer, that means it possesses 6 identical subunits. The specific row factor it takes the advantage of ATP for its accuracy. Is it okay? So let me write it here. Row factor, it is an ATP dependent helicase ATP dependent helicase, and it is an hexamer. So here, as we all know, the specific mRNA which successfully synthesizes during the transcription mechanism or in the transcription process, it is quite complementary to the template strand and it is quite homologous to the sense strand or the coding strand. So here at first we will be studying regarding row independent termination followed by row dependent termination in detail. Is it clear? So let me write it here. So let me arrange the things first. So here let us assume it as the 5' end. So here the complementarity of C is G, G, C. The complementarity of A is T in case of DNA, but whereas in case of RNA it is uracil. Is it clear? The complementarity of G is again it is C, C. And here the complementarity of C is G, G, and the complementarity of T is A, G, C, C. And here there is an availability of multiple uracil residues U, 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 and it is nothing but the 3' end. So here it is nothing but the mRNA sequence. So here the specific mRNA which successfully synthesizes during the transcription mechanism or in the transcription process, it is quite complementary to the template strand and it is quite homologous to the sense strand or the coding strand. So here in case of row independent termination, the specific mechanism, as the name itself suggests, the specific mechanism, it is successfully organized without taking the advantage of row factor. So without taking the advantage of row factor, the specific termination phase, it is successfully organized here. So the reason why it is termed as row independent termination. So here, as we all know, the complementarity of A is U. So once when there is an availability of multiple uracil residues at the extreme 3' end of the prokaryotic mRNA, under such condition, the specific nascent mRNA, it successfully dissociates from the site of the synthesis without taking the advantage of row factor. As we all know, the weakest hydrogen bonding in between the two successive nitrogen bases, it relays in between A and T in case of DNA. But whereas in comparison to A and T, the much more weaker hydrogen bonding, it relays in between A and U in case of RNA. So once when there is a base pairing in between A and U, under such condition, so due to the weaker base pairing or due to the weaker hydrogen bonding in between A and U, the specific nascent mRNA, it successfully dissociates from the site of the synthesis without taking the advantage of row factor. Is it clear? So the reason why it is termed as row independent termination, row independent termination, or it is otherwise termed as intrinsic termination. Is it clear? So let me present it on the board. So let me arrange the things here. So once when the specific nascent mRNA, when it successfully synthesizes during the transcription mechanism, the specific nascent mRNA, it possesses inverted repeats. So due to the presence of inverted repeats, the specific nascent mRNA, it acquires a specific secondary loop structure which is nothing but stem loop structure or hairpin loop structure. Is it okay? So let me present it here. 5' end, and it is nothing but the secondary loop structure. It is nothing but the 3' end. Is it okay? So here all these are the RNTPs. So here it is G, again it is G, again it is C, U, C, C. So here the complementarity of C is G. So let me use some other color here. The complementarity of C is G. Complementarity of C is again it is G. Complementarity of U is A. C is G. Again it is C. Again it is C. So these are the multiple uracil residues. So here the distance between the secondary loop structure and the multiple uracil residues, it is around 6 to 7 nucleotides. And it is nothing but what? Stem loop structure. Stem loop structure. So due to the presence of multiple uracil residues at the extreme 3' end of the prokaryotic mRNA, the specific nascent mRNA, it successfully cleaves or it successfully dissociates from the site of the synthesis without taking the advantage of Rho factor. So the reason why it is termed as Rho independent termination. And the other alternative strategy through which the termination of the transcription mechanism in case of prokaryotes, it is successfully organized. It is nothing but what? Rho dependent termination. Is it okay? So here it is Rho dependent termination. Rho dependent termination. Is it okay for you? So as the name itself suggests, Rho dependent termination, that means by taking the advantage of a specific factor termed as Rho, here the termination phase, it is successfully organized. So the reason why it is termed as Rho dependent termination. So what exactly happens during the Rho dependent termination? So here by taking the advantage of a specific factor termed as Rho, the specific nascent mRNA which successfully synthesizes during the transcription mechanism or in the transcription process, it successfully cleaves from the site of the synthesis. So the reason why it is termed as Rho dependent termination. Is it okay? So let me write it on the board. So let us we assume it has the 5' end. And it is nothing but the 3' end. Is it clear? And here it is nothing but the 3' end. And it is nothing but the 5' end. So all these are the nucleotides, right? So this is nothing but the RNA polymerase enzyme. RNA polymerase. And all these are the RNTPs which were synthesized during the transcription mechanism or in the transcription process. So here, as the name itself suggests, Rho dependent termination, that means by taking the advantage of Rho factor, here the specific nascent mRNA which successfully synthesizes during the transcription mechanism, it successfully cleaves from the site of the synthesis. Now here my question is, where exactly the specific Rho factor it successfully recruits to the nascent mRNA? In order to recruit to the nascent mRNA, the specific Rho factor, it takes the advantage of a specific consent site which is nothing but Rho utilization termination site. Is it okay? So let me write it here. What it is? Rho utilization termination site. Rho utilization termination site. Or it is simply termed as RUT site. So here the specific Rho utilization termination site, it is rich in high cytosine residues, and it is poor in guanosine residues. And it is poor in guanosine residues. Is it okay? So to the concerned site, the specific row factor, it successfully recruits here. So once when the specific row factor, when it successfully recruits to the row utilization termination site, which is rich in high cytosine residues and poor in guanosine residues, the specific row factor, by taking the advantage of ATP, it is capable to cleave the nascent mRNA. So here the specific row factor, it is capable to distinguish the specific nascent mRNA which is being synthesized and the specific nascent mRNA which has already participated in the translation mechanism. Because as we all know, in case of prokaryotes, both transcription and as well as translation, they are coupled. That means from one particular direction, synthesis of the mRNA, it is in progress, and from the other direction, synthesis of the protein is in progress. So here the specific row factor, it only binds to the nascent mRNA which is being synthesized, but not to the specific nascent mRNA which has already participated in the translation mechanism. So once when the specific row factor, by taking the advantage of ATP, when it successfully recruits to the row utilization termination site, under such condition, the specific row factor, by taking the advantage of ATP, it is capable to cleave the nascent mRNA from the site of the synthesis. Is it okay? So let me write it here. So what it is? Row factor. Row factor, which is an ATP dependent helicase. So by taking the advantage of row factor, here the nascent mRNA, it successfully cleaves from the site of the synthesis. So let us we assume it as the nascent mRNA. So all these are the RNTPs, right? So once when the specific nascent mRNA, when it successfully cleaves from the site of the synthesis, under such condition, the specific nascent mRNA, it is capable to participate in the translation mechanism in order to synthesize the polypeptide chain. So this is regarding row dependent termination. So these two are the alternative strategies through which the termination phase of the transcription mechanism in case of prokaryotes, it is successfully organized. So I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.